The next step we're looking at is the calculation of the axis. Each of the leads will give you a snapshot of the electrical activity traveling through the heart. Each lead has its own angle, as you can see here. So if a lead, like lead 2 for example, at 60 degrees is looking at the electrical impulse traveling directly towards it, we're going to see positive deflections on the ECG. On the other hand, AVR, which is at -150, as you can see there, is looking from the opposite side of the heart and the impulse is traveling away. So what we're going to get is negative deflections. What we're calculating when we calculate the axis is the direction of the electrical impulse as it's traveling through the heart. Most of the heart cells that are being depolarized are in the left ventricle because it's generally much bigger than the right. So we're typically going to see an axis towards the left side. The first thing we're going to do is use a shortcut to say whether the axis is normal or not. If the QRS complexes are positive in lead 1 at 0 degrees and in AVF, which is at 90 degrees, then we can say that the axis is normal. This is because a normal axis is between 90 and -30. More than 90 and we would have had right axis deviation, more than -30 and we would have had left axis deviation. In this example, AVF is negative, so unfortunately we can't use that method. What we're looking for is a biphasic wave. That means a wave, a little bit positive, a little bit negative. What this wave represents is a lead that is at 90 degrees from the true axis, or perpendicular to the true axis. If we don't have a biphasic wave, we can look for the closest to a biphasic wave, or the closest being isoelectric. In this example, AVR is biphasic, so we're going to be at 90 degrees from the true axis. We either go 90 forward or 90 back. But there's positive leads in lead 1 and AVL, the high lateral leads, so the axis is going to be in this general direction. Here we have an axis of -60, so there's left axis deviation.